So in the last video we have seen about the biochemical oxygen demand BOD. Now we will see the next one, that is called as COD, chemical oxygen demand. So before starting this, let me give you the basic difference between the BOD and COD. So in the BOD there is oxidation of only biodegradable organic matter. Okay, so only biodegradable organic matter oxidation is done in the BOD, that is, it is the amount of oxygen required for the oxidation of biodegradable organic matter. However, in case of COD, it is the amount of oxidation, or we can say it is the amount of oxygen required for oxidation of both biodegradable and non-biodegradable organic matter. So this is the basic difference. Okay, so you can see that in the first case we are calculating amount of oxygen required for the oxidation of only biodegradable organic matter. In the second case we are finding out the amount of oxygen required for the oxidation of both biodegradable and non-biodegradable. So if we compare BOD and COD, which one of these two is greater? Then COD is greater than BOD. Okay, COD is greater than BOD. So this relation we have got it from the definition itself. Now we'll start about the chemical oxygen demand, that is COD. So give the heading chemical oxygen demand. So we call it as COD. So write down in this. So it is the measure of organic content in wastewater, both biodegradable and non-biodegradable. Okay, so this is the major difference, and from this definition we can note this point that COD is always greater than BOD. COD is equal to oxidation of biodegradable plus non-biodegradable organic matter. Now the oxidation of biodegradable matter, this is called as BOD. Okay, we have seen the definition. So COD is equal to BOD plus non-biodegradable organic matter. So if you have to find out the non-biodegradable organic matter, so the definition is non-biodegradable organic matter. So how to find out this? So first we will find out COD and we will subtract it from BOD. So this will give us the non-biodegradable organic matter. Now this is all points about the chemical oxygen demand, COD. Now we'll move to the next one, that is called as total oxygen demand. It is also called as, there is one more name for this, that is TOC. So that stands for total TOC. It is total organic carbon. So we'll write down the third one, total organic carbon. that is TOC. So it is another method of expressing the organic content in the form of amount of carbon. Okay, so write down, it is another method, of expressing the organic matter, in terms of so we'll express the organic matter in terms of carbon content. Okay, so that is amount of carbon. In that term we will express the organic content. So we'll take one example also of this, but before that we'll write down the last one, that is the fourth one. So this is the third property, and the fourth property is, what is the fourth property? Theoretical oxygen demand, THOD. So theoretical oxygen demand, so we say it as THOD. So write down. So before writing out, first I will tell you, see, these all are the oxygen demands only, that is what is the amount of oxygen required for the oxidation of organic matter. So the first two that we have seen, the first two we are calculating it by doing certain reactions. See, this theoretical oxygen demand, this value we are calculating it theoretically, that is we will write the equations, and from that equations we will use the stoichiometry. Okay, in the organic or inorganic chemistry you must have learned about the stoichiometric calculations. So by doing the stoichiometry we will find out the amount of oxygen required to oxidize the organic matter, and that amount of oxygen we will call it as theoretical oxygen demand. So if the chemical formula if the chemical formula of all substances present in sewage is known, the amount of, so this is important, the amount of oxygen required to oxidize can be calculated using, so this method with which we are calculating this is called as stoichiometry. So it is called as stoichiometry. So we can calculate this stoichiometry, or we can say stoichiometrically. Okay, and this amount of oxygen is called as, this amount of oxygen is called as theoretical oxygen demand, THOD. Okay, now, so in general we assume that, or we take for the calculations part, THOD this is equal to COD for the practical purposes. But if you want to know the exact relation, then we'll just write it down here on the next page, that is relationship between all the oxygen demands, that is BOD, COD, TOC and THOD. So if we write the relation between this, the maximum among this or the largest one is THOD, as it is theoretically calculated. Then the next one is COD. After COD comes BOD, and the last one is TOC, that is total organic carbon. This is very important. Even this has been asked previously in UPSC examinations. So this is the relationship between all the BOD and COD, and we can say all the oxygen demands. Now we'll take one quick problem here. So calculate, or else we'll take the problem in the next video. Okay, so for this video we just revise the concepts here, and from the next video we'll take some numericals.